Are people interested in numerical differentiation and finite differences? I'm about to make some upgrades to my code. I used a very simple form of numerical differentiation, and I'm going to replace it with something more accurate. Does anyone want to see the details? Should I document the journey? Let me explain the problem. My input is a parametric function. You give it an input between 0 and 1, and it will return an x and a y. My output is a CSS-friendly path that approximates the input function. I'm using parabolas because they work well with CSS. There is nothing special about parabolas in the input domain. I love this hard example. It's so simple, but this is just for practice. In real life, I will have the parametric function and nothing else. That's why I have to use numerical methods to compute the slope at different positions. Initially, I really liked the way this heart turned out. Even when I zoom in, my approximation is good enough. But I added this table, and I can see an error of almost 0.25%. A normal person would let that go, but here we are. I know exactly what the problem is and exactly how to fix it. I bet I get 3 more digits of accuracy. The problem is especially obvious at the edges. Normally it's trivial to estimate the tangent of a function. Just pick 2 points, the same distance from the point you care about, and draw a line through them. A circle will give you a perfect result for a wide range of values. But I can't ask what's past the edge, so symmetry can't help me here. Again, these are ridiculously simple examples. I could solve these a number of ways, but I want a solution that will work for any parametric equation. Notice what happens when the 2 points get too close together. This is where real numbers and computer numbers differ. With real numbers, you can get as close to 0 divided by 0 as you want. That will give you a better and better estimate. In computer numbers, if you try to divide something close to 0 by something else that's close to 0, it's still indeterminate. And there isn't a hard edge, so you just want to avoid letting the points get too close together. Fortunately, I've seen this problem before, and I have a good solution all lined up. Please let me know if I should document the solution. There will be some useful information and interesting math.